Okay, so in this video we're going to be working through the VCAA Exam 2 for Maths Methods. As you are hopefully aware, this is a 2-hour paper plus 15 minutes of reading time, and it comprises 2 sections. Section A being made up of 20 multiple choice questions, and section B is, well, in 2016 was 4 extended answer questions. From year to year it sometimes changes slightly from 4 or 5 extended answer questions, but it's been 20 multiple choice questions for a little while there. Sometimes it's 22, but I think it's pretty much always been 20 multiple choice since 2016. Okay, so in doing the exam, obviously you would have a multiple choice answer sheet to answer on, but we'll just circle them on the question booklet here. The instructions on the front cover, are exactly the same. This is a tech active paper, so a CAS calculator, and you can also have a scientific calculator, but I'd strongly encourage you to just get used to working with your CAS calculator. Hopefully you're already used to it. There's big advantages in terms of being able to use previously calculated answers in future calculations, etc. Yeah, otherwise it's just basic nuts and bolts on the front cover. Once again, instructions at the top of the question section provide a bit more information, although the multiple choice, it's pretty straightforward really. It's just that you choose a correct answer, choose the response that's correct for each question, get 1 mark for a correct response, no marks for an incorrect response. You don't lose marks for incorrect responses, and you won't earn any marks if more than 1 answer is completed for any question. So do be careful about that when you're colouring in the dots on the multiple choice answer sheet. Sometimes it can be a bit easy to get yourself a bit out of whack and accidentally put colour in 2 circles on the 1 line, so do just be careful about that. Okay, let's just get into working through the questions. So question 1, the linear function f with an unknown domain. It has rule f of x equals 5 minus x, and it has range -4 to 5. The domain is. So one of the key things you need to be a bit careful about here is the function. It's a linear function but with a negative gradient. So it goes down as we go from left to right. Okay, so it's 5 minus x, which means, you know, it's negative gradient with a y-intercept at 5. The range is from -4 to 5. So if the range goes from being -4 to 5, okay, we must be talking about not including that and including that. So it includes -4 is included in the range, but 5 is not included in the range. So thinking about what that means for the domain, we're going to need to work out, it's clear that when the y value is 5, the x value is 0, but we need to work out when the y value is -4, what's the x value. So f of x equal to -4, that is 5 minus x equals -4. So negative x equals, equals -9, and x is 9. Okay, so this is clearly the point 9, -4, and that's an included point, and this is the point 0, 5, and that's a not included point. So the domain goes from 0, not included, up to 9, which is included. So the answer here should be option A. Okay, question 2, the period and range of this function respectively are. Okay, so we know that period is 2 pi on n, and in this case n is pi on 2, so that is 2 pi divided by pi on 2, which is 2 pi times 2 over pi, so the pi's cancel out, and the period is 4, so we've narrowed down to options A or B. And then the range is going to come from thinking about the amplitude and the translation up. Okay, so we've got an amplitude of 2 here, and the graph has gone up by 1. We could think about that as being -2 cos, and then a +1 at the end here. So up by 1. So with it up 1 and an amplitude of 2, the range is going to go from being 1 minus 2 to 1 plus 2. So 1 minus 2 is -1, and 1 plus 2 is obviously 3. So option B is the correct response there. Question 3. Part of the graph of f of x of the polynomial function f is shown below. Okay, so it's a polynomial, looks like it's probably a cubic. So this is the question. F dash of x is less than 0, 4, so where is the gradient, the derivative, negative? So it's clearly negative here, but not at that point, it's 0 there, and it's negative here, but not at that point, it's 0 there. So that is those x values or those x values. Okay, so from negative infinity up to negative 2, or from 1/3 up to infinity. So that is going to be option C. So D is similar, except it's got the, oh no, it's not similar at all. No, none of the others are even close. Okay, question 4. The average rate of change of the function f with rule f of x equals 3x squared minus 2 root x plus 1 between x equals 0 and x equals 3 is. Okay, so the average rate of change is going to be the change in the y values over the change in the x values, so we need to work that out. I'm going to get my CAS to do that for me. So I'm just going to quickly define the function. It's not to say I couldn't do it by hand, but again, it's about appropriate use of CAS, making good decisions. When is it going to be quicker, and when isn't it going to be quicker? Okay, so there's my function. Again, defining the function's a bit tedious, but ultimately it makes it a bit easier to then straight away now work out what is f of 3 minus f of 0 over 3 minus 0. So that is 25 on 3. D. Which of the following is the inverse function of g? Okay, so let's work out the rule of the inverse function first. The fact that the original function is a square root function means the inverse should be a quadratic, so that allows me to rule out C before I even think about anything. And this is where sometimes you want to think a bit differently in your strategy approaching a multiple choice question, or even if you don't know how to answer the question, can you at least eliminate one or two options so that if you are having to have a guess, you're guessing between a smaller number of options. So try and just take a moment of logical thought. Can you kind of rule anything out straight away? It's also probably pretty unlikely that the domain of the inverse is the same as the domain of the original, but so I'm thinking A is probably not correct, but let's work things out before we assume that. Okay, so g of y equals x for the inverse function, so that is square root of 2y minus 6 equals x. Squaring both sides, 2y minus 6 equals x squared, 2y equals x squared plus 6, and y is x squared plus 6 on 2. Obviously you can get your CAS to do that rearrangement for you if you need to. For me, I can do that quicker by hand. So remember, the outcome is about appropriate use of CAS, so making good decisions in order to ensure that you can complete the paper efficiently. Okay, so the rule is x squared plus 6 on 2, so that rules out B. And then the other options, the remaining options, are all about thinking about the domain. So we want to think about what g looks like. So g is a square root function. So this is actually, it's easy to think about the transformations if you factor out that 2. It's a square root graph dilated by half from the y-axis and then translated to the right by 3. So it's going to do something like that. Okay, and so therefore the range of g is from 0 to infinity, which means that the domain of the inverse is also from 0 to infinity. So it should be option D. Question 6. Consider the graph of the function, so it's y equals 2x, sine of 2x between 0 and 2 pi. The square of the length of the line segment joining the points on the graph for which x equals pi on 4 and x equals 3 pi on 4 is. Okay, so we really just need to know the coordinates of those 2 points. So I might define this function just to make life a bit easier. F of x equals, so f came up as bold, and that's because I've previously defined a function, but if I just define it again, it'll simply override it. So you don't need to worry about that. Sine of 2x. Okay, there's my function. I want to know what f of pi on 4 is. I want to know the y coordinate of pi on 4, it's 1. And I want to know what f of 3 pi on 4 is, so I'm just going to edit this and stick a 3 in front of that pi on the numerator. -1. Okay, so essentially we've got a line segment that's going to join the point pi on 4, 1, to the point 3 pi on 4, negative 1. And we want to find the length of that line segment. Let's try and draw that again. Okay, so the rise, the difference between negative 1 and 1, so it's clearly 2, and from pi on 4 to 3 pi on 4, that is pi on 2, or 2 pi on 4. And so therefore, we want to find this length here. Pythagoras tells us that x squared is 2 squared plus pi on 2 squared, so that is 4 plus pi squared on 4. Now we want the square of the length, so that is x squared. So yeah, as I said, the square of the length is going to be x squared. And so we just now want to get this to look like any of the options here. So if it's not going to be B or C, if I get a common denominator, I doubt it's going to be E. Common denominator here is 4, so this is 16 on 4 plus pi squared on 4. And so it is 16 plus pi squared on 4, which is option A. The number of pets, x. Now if you're doing exams in 2020, this is a question about discrete random variables, so this wouldn't be applicable to your 2020 study design, so you can skip over this question. But if you're doing it in future years, when this is still in the course, I'm going to cover all the questions in the paper. So the number of pets x owned by each student in a large school is a random variable with the following discrete probability distribution. So 50% of the students own no pets at all, 25% own 1 pet, 20% own 2 pets, and 5% own 3 pets. If 2 students are selected at random, the probability that they own the same number of pets is... Okay, so there's 4 different things that could happen here. The 2 students could both own no pets, or they could both own 1 pet, or they could both own 2 pets, or they could both own 3 pets. Okay, so if they both, the probability of both of them owning no pets would be the probability that x equals 0 times the probability that x equals 0. So to be that squared. Or they could both own one pet, so that's the probability that x equals 1 squared. Or probability that x equals 2 squared, or the probability that x equals 3 squared. Because they both have to own the same number of pets. So if you think about the tree diagram, you know, the first person could own 0, 1, 2, or 3 pets. The next person could then own 0, 1, 2, or 3 pets. Same number of pets would be probability of x equals 0 times probability of x equals 0. Or along this branch, probability that x equals 1 times probability that x equals 1. Or probability x equals 2 times probability x equals 2, etc. Okay, so let's just work these out. So that is 0.5 squared plus 0.25 squared plus 0.2 squared plus 0.05 squared. So that is 0.355. So C, 35% chance 2 randomly selected students both own the same number of pets. That's pretty high. Question 8. The UV index Y for a summer day in Melbourne is illustrated in the graph below, where T is the number of hours after 6 AM. The graph is most likely to be the graph of... Okay, so let's have a think about what we've got here. The first thing I'm noticing is that there's no horizontal translations in any of the options. Okay, so if the equations had horizontal translations, it would be possible to model this with a sine curve that had translated to the right or possibly to the left, but it's not. And given that there's no horizontal translations, it could be a positive cos curve if we thought about translating it to the right by that much. However, it hasn't been translated left or right, so it has to be a negative cosine curve. Okay, and so therefore, immediately, just by thinking through that, it has to be either B or D. So then I'm having a look at, okay, what's the difference between B and D? They've both got 5 minus 5 here. The negative is because it's upside down. The 5 at the beginning, they've all got that. That's because the graph has gone up by 5. Okay, we can then also see that the amplitude is 5. So that's those 2 5s. Okay, so they're both correct. And it's negative because of the reflection. So it's really just about the period. So we can see here that the period is 14. We know that period in a cos curve is 2 pi on n. That has to be equal to 14, which means 2 pi is equal to 14n, or n is equal to 2 pi divided by 14, which is pi on 7. And so our answer has to be B. Okay, question 9. Given that the derivative of x e to the kx is kx plus 1 times e to the kx, then the antiderivative of x e to the kx is equal to. Okay, so if you were to just use your CAS, which it'd be worth trying to see what happens, but I suspect that's defeating the purpose of the question, and it's not going to match, obviously, any of the answers that we get. So if we did x times e to the kx, antiderivative of that with respect to x, we find that it's this. Okay, so that doesn't immediately match any of the options. If we were to write that bracket with a common denominator, that's going to be kx over, kx minus 1 over k squared times e to the kx. So it's a minus 1, not a plus 1, so that doesn't match that either. So I'd say from that b's not right. And it's not going to be, you know, if we were to expand this out, this one here is nearly right. You'd need a k there. It'd be kx times e to the kx minus e to the kx. So that's not quite right either. And then this one definitely isn't right. Okay, so it's going to be to do with one of these options which still has an antiderivative in it, and so therefore that's going to force us to do some work by hand here. So if we know the derivative of this yellow thing is equal to this green thing, the derivative of the yellow is equal to the green, then that means that the antiderivative of the green thing has to be equal to the yellow thing. Okay, so that's what we learn. So we want to take that. Okay, so the antiderivative of the green thing, antiderivative of kx plus 1 times e to the kx is equal to x e to the kx. Okay, so let's have a think. We're interested in antiderivative of x e to the kx, so we need to focus on breaking up this antiderivative. So this is kx e to the kx plus e to the kx is equal to x e to the kx. We can split this into two integrals and take that k out of there. Antiderivative of x e to the kx dx plus antiderivative of e to the kx dx. Okay, so this is what we're interested in here. So that's our aim. So we want to simplify everything else and move it onto the other side. So if I subtract that other integral, I'm not going to evaluate it because I can see that my answer actually still has an integral in it. So it's x e to the kx minus the integral of e to the kx. And then we just need to divide by k. Antiderivative of x e to the kx is, now thinking about the options we've got here, it's going to be this one. We can just put the 1 on k out the front. 1 on k times x e to the kx minus the antiderivative of e to the kx with respect to x plus c. So it is going to be option D. Once again, like sometimes you don't need to work the whole thing through. Perhaps right from this point here, let me be clear about where I'm pointing, this point here, you can see you've ruled out 3 of the 5 options and you can see it's now not going to be this one either. So you probably don't need to work it right through to go, okay, it's D, move on. And you need to do that. The time allowance in exam 2 is very tight. You just cannot afford to waste time. Okay, so the most efficient way you can work through these multiple choice questions, the better. Bearing in mind that 20 multiple choice questions, you should be aiming to finish in 30 minutes. So if you are still working on the multiple choice at 30-minute mark, you need to stop, guess, and move on. If you have time to come back to them, great. If not, then you've put down answers and you had a 20% chance of guessing each of them correctly. Okay, so for the curve y equals x squared minus 5, the tangent to the curve will be parallel to the line connecting the positive x-intercept and the y-intercept when x is equal to what? Okay, so again, a lot of information here. So we've got y equals x squared minus 5. So that is a simple parabola just translated down by 5. Oops, sorry. And we're interested in a line that is parallel to the line that connects the positive x-intercept and the y-intercept. Okay, positive x-intercept and the y-intercept. Okay, so that's that line, but we want a line that's parallel to this and that's tangent to the curve. So it's going to be maybe somewhere about here. parallel to that pink line and tangent to the curve at what x value. This is what we're trying to find. Okay, so that's what we want to know. So we can work out what the gradient of the pink line is, because we know that this is root 5, 0, and this is 0, negative 5. Okay, so the gradient of the pink line is rise of root 5, no, sorry, the rise is 5 over the run, which is root 5, 5 on root 5. If we rationalise that denominator, that's 5 root 5 on 5, and so it's just root 5. So the gradient of the pink line is root 5, and therefore the gradient of the blue line is also root 5. Okay, and so we want to know where on the curve has a gradient of root 5. Okay, so we want to know derivative is equal to 2x, and that has to equal root 5, and so that will happen when x equals root 5 on 2. So option D. Function f has the property f of x minus f of y equals y minus x times f of xy for all non-zero real numbers x and y. Which of the following is a possible rule for the function? The quickest way to do these in the exam is to just get your CAS to test the options. Okay, so the first thing you want to do here, you just run through the options and hope it's not the last one. You might again try and do some logical thought, but you know, this is a pretty complex kind of relationship. I would simply just trial and error. So I'm going to define f of x as x squared, which is my first option A, and then I'm going to get my CAS to work out f of x minus f of y, and to see if that is equal to y minus x times f of xy. Careful with the xy, you want to make sure you type x times y, otherwise it will be calculating something different. Now, if this is true for all values of x and y, it will just write true. The CAS will tell me true. If it's not true for all values of x and y, it'll give me an equation, and it's only true for the solutions of that equation. Okay, so this is not true for all values of x and y. So I'm now going to redefine f of x again. Menu 1.1, defining f of x as, I could have just edited the previous calculation as well. Oh, sorry. Sorry, my touch is slightly out over here. I need to recalibrate. F of x is x squared plus x to the power of 4. And I don't need to retype this. I just want it to now, for my new definition of f of x, work this out. Nope, not true. Okay, so menu 1.1, define option C is, sorry, f of x is x times log e of x, so ln of x on my CAS. Get it to work out this identity again. Nope, not true for all values of x and y. Let's go again. You always hope that it's an earlier option, but anyway, it's clearly not. F of x is equal to 1 on x in option D. Evaluating the identity. So it is true for 1 on x. We can check that it's not true for 1 on x squared. So if I just slightly edit that, make it x squared. Yep, not true for 1 on x squared, so it is true when f of x is 1 on x. I know that's a little bit tedious, but it is the most efficient way to do it. Question 12, the graph of a function f is obtained from the graph of a function g with rule g of x equals square root of 2x minus 5 by a reflection in the x-axis followed by a dilation from the y-axis, a reflection in the x-axis followed by a dilation from the y-axis by a factor of a half. Which of the following is the rule for f? Okay, we can do these transformations in two ways. So if you think about what's happening to a point, you reflect it in the x-axis, its y-coordinate becomes negative. You then dilate it by a factor of a half from the y-axis, you're halving the x-coordinates. Okay, so the image of x is half x, which means that x is 2 times the image of x, and the image of y is negative y, which means that y is negative image of y. We want to take g of x, which is y equals square root of 2x minus 5, and apply these transformations. So replacing y with negative y dash, and replacing x with 2x dash. Sorry, it's minus 5. So negative y dash equals square root of 4x dash minus 5. So y dash is the negative square root of 4x dash minus 5. So, sorry, this one's g of x. and this is f of x. F is obtained after we do those things. F of x is negative square root of 4x minus 5. So that is option D. If you prefer it to do it directly with the function notation, okay, so you start with g of x, which was y equals square root of 2x minus 5. You then reflect it in the x-axis. That becomes negative square root of 2x minus 5. And that you then dilate by a factor of a half from the y-axis. So that is when we replace the x value with 2x. Okay, remember, dilating by a factor of a half is f of x becomes f of 2x. So replacing all the x's with 2x's. And so you get to the same answer we got to. So whichever method you're more comfortable with, it's not a particularly complex sequence of transformations, so probably working through just with your function notation is fairly reliable in this instance. But regardless, whichever way, option D is the answer. Okay, question 13. Consider the graphs of the functions f and g shown below. The area of the shaded region could be represented by. Okay, so let's think about what we actually need to do to calculate the area of the shaded region. It's not strictly an area between two curves, because it's only an area between two curves here, between here and here. Okay, and so then you wouldn't have thought about these bits. If you did it as an area between two curves from 0 to D, then you would need to think about what happens when that parabola extends, and it would be including bits of area in under here. Okay, so you need to be a bit careful. So the shaded region here, if we think about finding that total area there that I've just highlighted in blue, and then subtracting that bit of area there in pink is what we want to do. So that total blue area, that's going to be the integral from 0 to D of f of x. And then the pink area is going to be the integral from a to c of g of x. That b, the point where they intersect, that doesn't make any difference whatsoever. It's not like they're swapping what's top and bottom or anything like that. So that's meaningless. So we want to do the blue area, integral from 0 to d of f of x, minus the pink area, integral from a to c of g of x. And that is exactly what option E says. Okay, question 14. A rectangle is formed by using part of the coordinate axes and a point UV, where u is bigger than 0 on the parabola y equals 4 minus x squared. Okay, so given that you've got the rule, if the x-coordinate is u, the y-coordinate is 4 minus u squared. It tells you that y is 4 minus the x-coordinate squared. Okay, so that means that the area of that rectangle is, that is u, and that is 4 minus u squared. Okay, so it's simply just the x-coordinate times the y-coordinate. So it is u times 4 minus u squared, or if you prefer, 4u minus u cubed. Up to you. Okay, so I'm just going to define that. So we're trying to, which of the following is the maximum area of the triangle? So we want to maximize this area. So we know that to maximize the area, we're going to solve the derivative equal to 0. So I'm going to set my CAS up to how to do all that. I'm going to define a of u equal to 4u minus u cubed. I'm going to solve the derivative with respect to u of a of u. I'm going to solve that equal to 0 for u. And when I do that, I get that u equals plus or minus 2 root 3 on 2. But the question tells us that u has to be bigger than 0. And so u is going to be 2 root 3 on 2. It asks for the maximum area, so that's not the maximum area, that is the value of u, so the x-coordinate that will give maximum area. And so that means the maximum area, we're going to sub this back into our equation for area. And so in my CAS that's nice and easy because I've defined that function for area. So it's going to be a of 2 root 3 on 3. And that is 16 root 3 on 9. Okay, Question 15. Box contains 6 red marbles and 4 blue marbles. 2 marbles are drawn from the box without replacement. The probability that they are the same colour is. Okay, so we can draw a red or a blue on the first selection and then a red or a blue. They're drawn without replacement, so the probabilities will change at the second stage. So we've got 6 red marbles and 4 blue marbles. So 6 in 10 or 3/5 of the marbles are red, 4 in 10 or 2/5 are blue. Then after we've selected a marble, so after we've chosen a red marble, we now have 5 red marbles and 4 blue marbles. So that means 5 knights are red and 4 knights are blue. If we've selected a blue marble first, we've now got 6 red and 3 blue. Okay, so that is 6 knights, which is, I'm going to leave it as knights just so we've got the common denominator for when we do the calculation in a minute. 6 knights and 3 knights are blue. So we want the probability that they're the same colour, so that's going to be the probability of red and then red, or so plus the probability of blue and then blue. And so that is 3/5 times 5 knights plus, oh sorry, I shouldn't have worried about the denominators, I've got my cas. I can get it to do it all for me, but anyway, that's okay. 2/5 times 3 knights for blue and then blue. So that's 15 on 45 plus 6 on 45. 3 is a common factor in both of those, so that's actually 5 on 15 plus 2 on 15, so 7 on 15. Once again, kind of quicker for me to do that by hand than to bother typing all those fractions in. But again, up to you, and it's about appropriate use of cas, not lots of use of cas. Okay, question 16. The random variable x has a normal distribution with a mean of 12 and a standard deviation of 0.25. If the random variable z has the standard normal distribution, so that is a mean of 0 and a standard deviation of 1, then the probability that x is greater than 12.5 is equal to. Okay, so we need to know how to standardize, and I actually think I might be confusing the further sheet. It's not on the formula sheet. No. So the rule for standardizing isn't on the formula sheet. So a z-score or a z-value is the original score minus the mean of the original score divided by the standard deviation of the original score. So if we want the probability of x being greater than 12.5, that is the same as the probability that z is greater than 12.5 minus 12 over 0.5. Which is, sorry, over 0.25, my apologies, which is the probability that z is bigger than, so that's 0.5 on 0.25. How many quarters are in a half? Sorry, should be 2. Again, you've got your cas to help you with the numbers if you need. So probability of x being bigger than 12.5 is the same as the probability of z being bigger than 2. Now, if you actually think about what z-scores mean, that can actually be a more efficient method here. So a z-score tells you how many standard deviations away from the mean you are. So this is saying that a score of 12.5 is 2 standard deviations above the mean. And actually, if you thought a bit about the numbers here, you could have worked that out. So if you've got an x value of 12.5, that is 2 standard deviations higher than the mean, and so it will equate to a z-score of 2. It definitely isn't a negative z-score. It's a value that's higher than the mean. And yeah, sometimes these questions ask you to think about symmetry, like it might have said it's the same as the probability of z being smaller than -2. That would be the same thing, and you'd have to identify the symmetry, but this one's straightforward. Option E is the direct answer. Okay, question 17. Again, if you're doing this exam in 2020, this is the statistical inference topic. This is not on the 2020 study design, so you don't need to answer this question. Similar for question 18, which is a continuous random variable, so also another question you don't need to answer. So question 17, inside a container there are 1 million coloured building blocks. It is known that 20%, so that's essentially saying there's lots of them. It's known that 20% of the blocks are red. A sample of 16 blocks. Yeah, so what that's about is that the probability won't we can assume the probability won't change from as blocks are selected. So technically, if you take out, one red block, that will change how many of what the proportion of the red blocks in the remaining 999,999 blocks that are red. But it's such a large, the fraction's so large, the denominator's so large, and the numbers are so large that actually it's still very close to 20%. So essentially, we can sort of assume that the probability of making any selection is 20% chance of getting a red. Sample of 16 blocks is taken from the container. For samples of 16 blocks, p hat is the random variable of the distribution of sample proportions of red blocks. Do not use a normal approximation. Okay, so essentially we need to use the binomial. We want to know the probability that p hat is bigger than 3 on 16. Let's be just clear about what's happening here. So I'm going to define a binomial variable where x is the number of red blocks in the sample, and x is a binomial variable. We're choosing a sample of 16 and the probability that it's red is 0.2. Okay. Now p hat is equal to the proportion of red blocks in the sample. So what that means is that p hat is the same as x divided by 16. Okay, so if there's 2 red blocks in the sample of 16 blocks, the proportion of the sample that is red blocks is 2/16. Okay, so this means that x is equal to 16 times p hat. So what that means is, if I want to know the probability that p hat is bigger than or equal to 3 on 16, that is the same as the probability that x is bigger than or equal to 3. If I want to know the probability of the proportion being 3/16, then that means that the number of blocks in the sample has to be 3. And so then we just use our binomial. So menu 55B for normal CDF. We want number of trials is going to be 16. Probability of success is 0.2. The lower bound here is 3 and the upper bound is 16. And so that is approximately 0.6482, which is A. Okay, question 18. So again, a continuous random variable, so not on the 2020 study design. Continuous random variable x has a probability density function given by this. The value of a such that the probability that x is less than a is whatever. Okay, so we've got some kind of cos function, whatever it looks like, it doesn't really matter. Just imagining you've got some sort of probability density function. You want the probability that goes from, only from 3 pi to 5 pi. You want the probability that a is less than a particular value. It has to be equal to root 3 plus 2 over 4. So therefore, what you know here is that the integral from 3 pi up to a of our probability density function has to be equal to root 3 plus 2 over 4. And we'll just get our CAS to solve that for A. So we're going to solve shift plus for antiderivative, 3 pi to A. I used A, I called the function A before. I'm just going to use B in my CAS, but make sure it's not a short answer question, but make sure that you use variables consistent with the question on the paper, but you can obviously change it in your CAS. A quarter times cos, making sure you're in radian mode as well. That should be default at the start of, you should have checked that at the start of the paper when you're working with trig. So antiderivative of a quarter cos of x on 2 from pi on 3 up to an unknown value, which I've called b, has to be equal to square root of 3 plus 2 over 4. And we want to solve that for b. I'll need to give b a restriction because it's a trig function. So we know that b is going to have to be somewhere between 3 pi and 5 pi. Okay, so 3 pi is less than or equal to b, which is less than or equal to 5 pi. Okay, so b in my CAS, but a here on the paper is not approximately, it is exactly 14 pi on 3, which is option B. I'm just going to clear A to Z in here just so I don't have that problem with A happening again. So menu 1, 4, clear A to Z. Now if I type the letter A, it's not bold, so I can use it for other things. Okay, nearly there with multiple choice. Question 19. So again, this is a discrete probability distribution. So for those sitting the exam in 2020, not relevant to your study design. So consider the discrete probability distribution with random variable x shown in the table below. The smallest and largest possible values of the expected value of x are respectively. Okay, so let's have a think about what's happening here. So first of all, we can get a connection between A and B. We know just from adding up the probabilities that A plus 4B plus 0.2 has to equal 1. So A plus 4B has to equal 0.8, or A has to be 0.8 minus 4B. Okay, so we definitely know that. Expected value of x is going to be, remember it's the x value times its probability. So -1 times A, that's -A, plus 0 times B, that's 0, we won't worry about that, plus B times B, that's B squared, plus 2B times 2B, that's 4B squared, and plus 4 times 0.2, that's 0.8. Okay, so that means the expected value of x is going to be -A plus 5b squared plus 0.8. Now I'm going to put my a in here. So we've only got expected value in terms of b, just the one variable. So we know that it's -0.8 minus 4b plus 5b squared plus 0.8. So those 0.8s are going to cancel out. And we've got negative 4b, so that's 4b plus 5b squared. Okay, so let's think about what's happening here. I might just factorize this just so I can see what's happening. 4 plus 5b. So if I think about the expected value of x, what that looks like graphically, don't ever be afraid to draw a graph. It's amazing how helpful they can be sometimes. So that's a parabola with x-intercepts at or b-intercepts at 0 and -4/5, so -0.8. Okay, so this is the expected value of x versus b. Okay, now obviously b can't be a negative number, so we're not actually interested in any of that. So what we want to think about though is what is the smallest and largest possible values of the expected value of x. So we can see the smallest value of expected value of x is going to have to be 0. Because if b can't be less than 0, then therefore the lowest point on this expected value of x graph is 0. So immediately we can go to options C or E. Okay, and then we want to think about, okay, well, what's the maximum value of the expected value of x? And therefore what we want to think about is what's the biggest possible value of b? Alright, so let's think through what's happening up here. So it's probably easier to think a little bit about A because there's only one of those, and then we'll work out what that means for B. So I know A can't be any bigger than 0.8 because if it's bigger than 0.8 we've got total probability more than 1. If A is 0.8, this B will be 0, and so we've got a probability distribution that works with the total probability of 1. And obviously A can't be a negative probability, so it has to be bigger than 0. So we know that A has to be somewhere between 0 and 0.8. Okay. So if A has to be somewhere between 0 and 0.8, we can work out what that means for B. Okay, because A is 0.8 minus 4B. Oops, that's a 0. So subtracting 0.8. Oops. And then dividing by -4, so -0.8 divided by -4 will be 0.2, so that is 0.2, has to be less than or equal to b, which is to be less than or equal to 0. Oh, sorry, I divided by negative, so I've got to flip my signs around. Okay, so we know that now b, if a has to be between 0 and 0.8, b has to be between 0 and 0.2. Okay, so that makes sense. The other thing you probably could have thought about the logic, you could have done the same as what we did with A. You could have said, okay, well, all of those together, 4B, they have to be, at most, they have to be less than or equal to 0.8. And so that means that B has to be less than or equal to 0.2. And obviously B has to be positive as well, so it has to be somewhere between 0 and 0.2. So if B has to be somewhere between 0 and 0.2, it can't be any more than 0.2, so we're going to stop here at 0.2. Let's work out when B equals 0.2, what does that mean for the expected value? Okay, so that is 0.2 times 4 plus 5 times 0.2, and that is 1. Okay, so therefore the maximum value of the expected value of x is 1 and the minimum value is 0. So E is the correct answer there. And then question 20, the final multiple choice question. Consider the transformation as defined by the matrix equation. The transformation T maps the graph of y equals f of x onto the graph of y equals g of x. If the integral of f of x from 0 to 3 is 5, then what is the integral of g of x from negative 3 to 0? Okay, so what we want to think about here is you need to be able to interpret what this is telling you. T of x, y, that's just the transformed version of x and y, so I call that x dash and y dash, the image of x and the image of y. And if we expand all this out, we're going to get negative x plus 0, and we're going to get 3y plus 5. Okay, so we know that x dash is equal to negative x and y dash is equal to 3y plus 5. So this means that if the image of x is negative x, we've got reflection in the y-axis to get from f to g. And if y dash is 3 times y plus 5, so multiplying the y values by 3 is a dilation by 3 from the x-axis, and then a translation up by 5. Okay, so let's just think about what that means graphically then. So we don't know what the equation of f of x is. I'm just going to draw some kind of function. Okay, let's say that's y equals f of x. Okay, so if that's y equals f of x, and what we know is that when we integrate that from 0 to 3, it's 5. So that area there is 5. Okay, so that's what we know. So then what we want to think about is to get from f of x to g of x, we do this series of 3 things. So we reflect it in the y-axis first, which is going to do that. Okay. Then we dilate it by a factor of 3 from the y-axis, from the x-axis, sorry. So that's going to make it taller, even taller than that probably. So if we think about what's happening with the area, so when we flipped it, okay, so what we now know is that that area between negative 3 and 0 would have been the same. Then if we're now multiplying it, dilating it by a factor of 3 from the x-axis, we're multiplying that area by 3. Okay, so now this area here is 15. Right. So now it is, that area there is, in total is 15. It's 3 times 5. And then we're also going to shift this graph up by 5. Okay, so then if we translate it up by 5, okay, we're literally taking that pink area and moving up by 5. So that bit up there, that's still 15, but we've moved up by 5. So this is adding on 5. And so the height of that is 5 and the width of that is 3. So the area of this is also 15. So therefore, the integral from negative 3, so this is y equals g of x. The integral from negative 3 to 0 of g of x is, the negative 3 to 0 is just about to do with the reflection, so that's how that connects. And g of x has been dilated by 3 from the x-axis, so that's going to triple the area, making it 15, but then also translating it up by 15 means that we've got this flat rectangle area here that is 3 by 5, so also 15. So it's going to be 15 plus 15, and so it is going to be 30, that integral there, g of x. Okay, I mean, you can obviously, you can do more general things than that if you want. You can sort of think about, that g of x, g of x would be equal to, what's it going to be, 3 times f of negative x plus 5, and kind of try and think algebraically about it, but this is going to be a bit harder to deal with. But you can certainly see that if you know that the integral of f of x from 0 to 3 is 5, then this is going to triple that, and then you're also going to be adding on the 5. Yeah, but it's probably a bit more complicated to do it algebraically. You really do need to think about it graphically. It makes a big difference to being able to see what it is that's happening. Please don't be afraid to sketch graphs. They're really helpful and important in visualizing what the question's asking you to do. Right, I'm just going to pause the recording here before I move on to section B. But I will post it all as the one video. It'll be a long video, but you know what questions are coming, so you can fast forward to the bits of the video that are relevant to you. Okay, and so now we're continuing with the 2016 paper, section B. Again, being familiar with those standard instructions. In all questions where a numerical answer is required, an exact value must be given unless otherwise specified. In questions where more than one mark is available, appropriate working must be shown if you are to earn full marks. Okay, let's work our way through question 1. We've got 4 extended response questions here. Question 1 is worth 11 marks. So we've done 20 marks worth of multiple choice, so there's 60 marks remaining in these 4 questions. So they should average 15 marks, so therefore question 1's a fairly short question. There'll be other questions that are longer. Okay, so we've got a trig function, restricted domain from 0 to pi, and it's a cos function. Find the period and range of f. Okay, so the period we know is 2 pi on n. In this question, n is equal to 1/2. Okay, so it's the coefficient of x inside the cos function. So that is 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi for the period. So this domain, we're seeing 2 complete periods of the cos curve. The range, we need to consider both amplitude and translation up. So we're going up by pi, and we have an amplitude of 2. So if we've gone up by pi, that's the average of the cos curve. Okay, so it's pi at the middle, y equals pi in the middle. And then amplitude is 2, so up 2 from here and down 2 from here. So therefore, the range goes from pi minus 2 up to pi plus 2. 2 marks for 2 things. It'll simply be a mark for 4 pi and a mark for the correct range. State the rule for the derivative function f dash. Okay, so one of the other things we want to think about is efficient use of our CAS through these problems. So one of the first things I generally do at the start of any extended response question, you usually have a function somewhere. I would be defining that so that I've then got it whenever I need it. 2 times cos of x on 2 plus pi. Okay. State the rule for the derivative. Okay, so obviously we can get our CAS to do that for us. We need to be a bit careful. Sometimes with trig functions, it gives you slightly strange versions that are not very familiar to you. But in this case, that would be what we'd get by hand as well. The derivative of cos is negative sign. We need to divide by the coefficient of x, so multiply by the coefficient of x when we're differentiating. So multiplying by half, 2 times a half is 1. So we're just getting negative sign of x on 2, and then the derivative of a number is just 0. But again, no excuse for getting that wrong when you've got your CAS with you. Obviously, you've also got access to the formula sheet with how to differentiate sine and cos functions, but your CAS is the much more useful tool here. So f dash x is negative sine of x on 2. That's a 1 mark question, 1 mark for the answer. Find the equation of the tangent to the graph of f at x equals pi. Now, this is a 1 mark question, and I want you to see that. They've given you lots of lines here for those of you that want to do this by hand, but your CAS does this very easily. I don't know why, but it doesn't matter how many times I tell my students your CAS can find an equation of a tangent really easily. They still always insist on doing these by hand. There's no benefit here. You want to save time wherever you can. So menu 4 for calculus, 9 for tangent line. We want the tangent to f of x, comma, when x is equal to pi. Great. So the equation of the tangent, it has to be an equation, so y equals, don't just write down 2 pi minus x, y equals 2 pi minus x, or you might write that as negative x plus 2 pi. So gradient of negative 1, y-intercept at 2 pi. Okay, easy so far. Part D, find the equations of the tangents to the graph of f, that's the same f, isn't it? Hasn't changed. Yep. That have a gradient of 1. Okay, so our tangent here had a gradient of -1, so we want to find the equations of the tangents that have a gradient of 1. So we first of all want to work out, okay, well, where is the gradient equal to 1? For which x values does the gradient equal 1? And we obviously need x to be between 0 and 8 pi. There would be infinitely many points, but we want the ones between 0 and 8 pi. So we're going to solve our derivative equal to 1 for x, and because it's a trig function, we need the domain restriction. Given that 0 is less than or equal to x, which is less than or equal to 8 pi. Some people prefer to define their functions with the domain, but I find that creates a lot of problems in lots of calculations. So I never define the function with the domain, I just add it in where I need it. And so this is when x equals 3 pi or 7 pi. Okay, so we just need to find two equations of tangents. Again, our CADs can do that for us. So the tangent at x equals 3 pi, well actually we can just edit our previous calculation up here. So the equation of the tangent when x equals 3 pi is going to be x, so equation, so y equals x minus 2 pi, and the tangent at x equals 7 pi is going to be I'm going to edit my previous calculation. Tangent when x equals 7 pi is going to be y equals x minus 6 pi. Now this is a 2-mark question. I'm not sure that the 2 marks would be for the two different equations of the tangents. I think 1 mark would probably be for identifying these x values, and then 1 mark for both of the tangents. But I didn't mark these exams, so I can't be sure, but just as that would be my guess. That's how I would mark it anyway. The rule of f dash can be obtained from the rule of f under a transformation t, such that this is t. So the rule of the derivative can be obtained from the rule of the original function. So what we really need to think about here is we really actually need to think a bit about the graphs and see really clearly what is happening here, okay? Because one's a sine graph and one's a cos graph, but the reality is that those are both just, sine and cos graphs are just transformations, translations of each other. So even though they're different functions, we should be able to get from one to the other just using a series of transformations, but it will be hard to do that algebraically, and it will be easier to be able to think about what's happening graphically. Okay, so let's think about our original function was 2 times cos of x on 2. So we already worked out that's a period of 4 pi and a range from pi minus 2 to pi plus 2. Pi minus 2 is a positive number, so the whole graph's above the x-axis. So from 0 to 8 pi, we're going to see 2 complete cos graphs. So let me just be clear about that. Let me just think about what my derivative is. So it's a reflected sine curve with an amplitude of 1, hasn't translated up or down, and it has the same period. Okay, so let me just think a bit about what's happening here. So we've got 8 pi, 4 pi, so we're going to see 2 complete cos curves. I'm going to say pi is about 3.14, so pi minus 2 will be bigger than 1, is what I'm trying to think through. Okay, so I'm going to make that 1, for example, negative 1 down here. So let's make, probably haven't got a very good scale here, but that's okay. Pi, and let's say pi plus 2. Alright, so our cos graph, no translations, wasn't reflected, was it? Let me just go back over here. No. So no translation left or right, I meant. Okay, so we're going to have something like this. Okay, so this is y equals f of x, and then the derivative is negative sine of x on 2. So it's got an amplitude of 1, it's a reflected sine graph, it's got a period of 4 pi. So, and obviously you can use your CAS to help you draw these as well. I find thinking through though means that you've got the information all a bit more precise. Okay, so that's essentially y equals f dash x, a bit more precise in your head, I mean. So find the value of a and the value of b. So we want to think about how do we get f dash can be obtained from f. So how do we get from the black curve to the blue curve? So the first thing is to translate it down so that its center is also at 0, 0. It's got the same period, so we don't need to do any dilating from the y-axis, but we are going to need to do the dilation from the x-axis, but we don't want to do that before we translate it down so that it's actually got its center on the x-axis. Okay, so we need to translate down by pi, and so that will move the graph. Down to here. Not exactly, but at least move it so it's got its center at pi. Now the other thing is we're going to need to do a translation so that the maximums and minimums align. So if we think about this, once we move it down, it's going to come down sort of under here somewhere, but I need the minimum to align, so I'm going to need to translate it to the left by, now that's 2 pi and that's pi, so it needs to go to left by pi. In translation, left by pi, so down by pi and left by pi. The left by pi is actually already showing, that's that there. So the down by pi means that b is going to be negative pi. Okay. And then, what else do we need? We then need to dilate from the x-axis. So the amplitude of the f is 2, but the amplitude of f dash is only 1. Okay. And so therefore we need to dilate by half from the x-axis. Okay, and that's going to be about this. We want to halve all the y values, so we want a to be equal to a half. Okay, and so therefore a has to equal a half and b has to equal, what do we say, negative pi. Find the value of a and b. Okay, 3 marks is a bit interesting here. I'm not sure what obviously 1 mark for each of those, definitely. I'm not sure exactly what the 3rd mark would be for, whether it's about identifying the transformations correctly, whether you're seeing that through a graph or just written out or something along those lines. But you're definitely going to need more than just the answers written in the space. I've just realised why this is 3 marks, and this is where it's important to think about it. These aren't in the right order. If I make b equal negative pi, that is happening after the dilation by half from the x-axis. I'm translating down by pi after I do the dilation, which will actually change what's happening. So that's actually not going to be correct. So we need to think about what we need to happen here. So if let's expand this out. So this is telling us that x dash y dash, which is what the transformed version of x and y are, is equal to x minus pi, and this is ay plus b. Okay, so x dash has to equal x minus pi and y dash has to equal ay plus b. Let's think through this sequence of transformations. So if you take a point and you translate it down by pi and left by pi, you're going to get x minus pi and y minus pi. And then if you dilate it by half from the x-axis, you halve its y-coordinate, so you halve all of that. Okay, so it's x minus pi times half of y minus pi, which means that this is x minus pi times half of y minus pi on 2. So thinking about our y dash equals ay plus b, well this is y dash, so a is a half, we had that right, but b isn't negative pi, b is negative pi on 2, and that's because it has to happen before you then dilate by half. Okay, so a is going to be equal to 1/2, and b is going to be equal to negative pi on 2. So there's probably going to be 2 marks associated with the b equals negative pi on 2, and then the a, well, 1 for each of those, but yeah, one for actually sort of some of the algebra that's needed here in thinking about the effect of that sequence of transformations. It might still be what I said before, a mark each for A and B and a mark for identifying the sequence of transformations essentially, whether you've done that in that way or in this way. But then, yeah, I'd say that's probably where we're at. So lucky I thought about the mark allocation. I had my answers wrong. Okay, so part F, and apologies if things have jumped around a little here and the CAS has changed. I had paused the video and then I worked the next full question and realised I wasn't recording. So I've erased it all and I'm back to here, but I've had to redefine f of x for this question in my CAS because I just need it to do this last part. So we want to find the values of x, where x is between 0 and 8 pi, such that f of x is equal to 2 times f dash of x plus pi. Now, I'm sure that they would really like you to think a bit about what's happening in this question, and that is that we are taking the derivative function, which is the blue graph above, okay, and we are dilating it by 2 and shifting it up by pi, and so we're getting a graph somewhere up here and we're finding the points of intersection. But really, this is a very trivial question when you've got your CAS. Now, it is worth 2 marks. I suspect that the 2 marks will be all for answers, having at least one answer correct and then having the complete set of answers, so all within the domain. But all the same, I am just going to rewrite out, and I know it seems trivial, I am just going to rewrite out the equation that I'm solving, even though it gives me the equation. I don't think you should need to do that, but again, the 2 marks here for what is essentially punch an equation into my CAS and write down the answer is making me a little nervous. So f of x, solving f of x equal to 2 times the derivative, so shift minus, of f of x plus pi. And we're solving that for x. It's a trig function though, so we need the domain restriction to get the ones we want rather than a general solution. So where x is between 0 and 8 pi. Okay, and we get x equals 3 pi on 2, 7 pi on 2, 11 pi. Sorry, to be clear about that. 11 pi on 2 and 15 pi on 2. As I said, I think the 2 marks would all be here, at least one of these correct for 1 mark, all 4 correct with no missing and no extras for 2 marks. Okay, question 2. I have already done this, but that's okay. Right, I'm going to define that function before I start. So defining f of x equals negative 1/3, oops, 1/3 times x plus 2 times x minus 1 squared. Alright, given that g dash of x, the derivative of g, is equal to f of x, so this function here is a derivative function. That's the derivative of g. Show that g is equal to this. Okay, so if g dash x is equal to f of x, that means that g of x is equal to the antiderivative of f of x. Now, I know you can get your CAS to do, we can get our CAS to find the antiderivative of f with respect to x, and it gives us that. It's not in the nicest format, but what I would probably do, given that it's a show that, I've always said to you, I think you really need to be explicit about what's happening in a show that question. You know, it's up to you, up to you to illustrate exactly what is going on. So I'm actually going to do the anti-differentiation, but in order to do that, I'm going to get my CAS to expand out f of x. So expanding f of x is negative x cubed on 3 plus x minus 2 on 3. I can do that anti-differentiation myself, so that is negative x to the 4 on 12 plus x squared on 2 minus 2x on 3 plus c. And then I know that g of 0 is 0 plus 0 plus 0 plus c, and that's 1. And so that means that c is equal to 1. And so therefore, g of x is negative x to the 4 on 12 plus x squared on 2 minus 2x on 3 plus 1 as required. Find the values of x for which the graph of g of x has a stationary point. So we want to solve g dash of x equals to 0 for stationary points. We know that g dash is f of x, so that's f of x equal to 0. And actually I can do this by hand, solving that equal to 0. I know that's x equals -2 or 1, but if I want I can do that with my CAS. So menu 3.1, solving f of x equals 0 for x. Yep. I'm just going to define g of x as well. So we'll need that as we work through this question. So g of x is negative x to the power of, sorry, not squared, x to the power of 4 on 12 plus x squared on 2 minus 2x on 3 plus 1. Okay, good. So we've got that. Okay, so just before we move on, again, when I finish a question, I always go back to reread the question, be clear, have I answered what it asked for? It asked for the values of x, good, so I don't need coordinates. So x equals -2 and 1 is correct. Okay, the diagram below shows part of the graph of y equals g of x. Okay, so that's the quartic that we were given up here. So this is what we're seeing. The tangent to the graph at x equals 2. Okay, so we're seeing the tangent to the graph at x equals 2. So that's telling us that the x coordinate of this point A is 2. And that this is the tangent. Tangent to g at x equals 2. And we've also got a straight line drawn perpendicular to the tangent to the graph at x equals 2. Okay, so that means that the perpendicular line is obviously the normal. Normal to g at x equals 2. The equation of the tangent at the point A with coordinates 2g of 2 is, okay, so this tangent has equation y equals 3 minus 4/3 x. Okay, so immediately then I know the coordinates of b, it's the y coordinate of the tangent, and so it's going to be 0, 3. Alright, so, look, b part 1, find the coordinates of b. Okay, so we've got those. It's a 1-mark question, so you can just write down the answer. It's the y-intercept of y equals 3 minus 4/3 x, and so this means that b is 0, 3. The coordinates of b are 0, 3. Find the equation of the line that passes through AC, and hence find the coordinates of C. Okay, so we already know the line that passes through AC is the normal to G at x equals 2. Okay, so the equation of AC, let's get our CAS to work out the normal. So menu for A for normal line. It is the tangent to G of x, which I've defined, comma, when x is equal to 2. Sorry, not tangent, normal to G of x when x is equal to 2. And good, that marries with what I'm expecting. I knew that the tangent had a gradient of -4/3, so what I did know from that is the normal has a gradient of +3/4. And so that is confirmed by the equation I found with my CAS, so I'm happy that everything's making sense. So y equals 3/4 x minus 7/6, and hence find the coordinates of C. So C is the y-intercept, and so therefore it will be 0, -7/6. Okay, so up here, this point is 0, -7/6. Part 3, find the area of triangle ABC. Okay, so let's have a look at what we're dealing with here. So triangle ABC is this triangle here. Okay, so we actually know this length here from B to C because we know the coordinates of B and C. So it's 7/6 that bit and it's 3 that bit, and so adding 3 onto 7/6, 3 plus 7/6 gives us 25/6 is that. And we know that this distance, the perpendicular distance, the height of the triangle is 2. It's the x coordinate of the point A. So what we have here is we have a triangle where that distance there is 25 on 6, and that distance there, the height of the triangle, is 2. Okay, and so therefore the area of triangle ABC is going to be half times the base length, which is 25 on 6, times the height, which is 2. Half times 2 is just 1, and so the area is just 25 on 6 square units. Okay. Part C. The tangent at D is parallel to the tangent at A. Okay, so we've got all our information here. Let's be clear about what's happening here again. This was y equals 3 minus 4/3 x. This one, no, not this one. This was y equals 3/4 x minus 7/6. This is the point 2. Let's work out the y value while we're here in case we need it at some point. G of 2 is a third, 2 1/3. This point up here was b, that's 0 3. This point down here is 0 7/6, negative 7/6, sorry. Alright, so let's be clear about everything. So D is parallel to the tangent at A. The tangent at D is parallel to the tangent at A. Okay, so these two lines are parallel, which means that this line has the same gradient. So the gradient also is negative 4/3. So finding the coordinates of D is the point on the graph of G with a gradient of negative 4/3. So we want G dash, the derivative of G, to be equal to negative 4/3. So if we want, remember the derivative of G is F, we want that to equal negative 4/3. Negative, 4/3. We'll expect 2 to be a solution to this, but there should be another value as well. Okay, so that happens when x equals negative 1 or 2. We actually found those values before, didn't we? Weren't they the two? No, negative 2 or 1 with the stationary points. Okay, so x equals negative 1 or 2, so 2 is the tangent at A, okay, and so therefore D, so let's work out, the y value, so G of negative 1, okay, so G of negative 1, so making sure we're subbing into the right function, so the graph is G of x, so that's 25 on 12, okay, and so therefore the coordinates of D are negative 1, 25 on 12. Okay, so find the length of AE. Okay, so AE is this distance here. So we're going to need to find the coordinates of the point E first. We've got the coordinates of A. So the coordinates of E is where the normal, which is this equation, intersects with the tangent at D. So we need to find the equation of the tangent at D. And now we know that D is when x equals negative 1. So menu 4, 9 for tangent line. Tangent to G of x, comma, when x is equal to negative 1. Okay, so the tangent at D is y equals 3/4 minus 4/3 x. Okay, and the normal at A was y equals, 3/4 x minus 7/6. E is the point of intersection. And so we want to solve 3/4 x minus 7/6 equals 3/4 minus 4/3 x. So we're going to be solving that, equal to, now I should have that 3/4 x minus 7/6 not too far back here, there it is. That equal to that, 4x. Okay, so that is when x is equal to 23 on 25. Okay, and so E, let's sub that into G of x. Oh no, sorry, E isn't on G. E is on both of those lines, so let's sub that back into either of these. So this means that y is going to be equal to, so I've got this one here, so I'm going to use this one. So we want to know that, given that x is that, so that's the quickest way to use the given that to make that substitution, because then you can just copy and paste your previous line. So y is negative 143 on 300. Okay, so this means that E has coordinates of 23 on 25 and negative 143 on 300. Okay, so then we want the distance. We've got A, we know that A is 2 1/3. Okay, we know that A is 2 1/3, and so therefore the distance from A to E is going to be the square root of 2 minus 23 on 25 squared plus 1/3 minus negative, so plus 143 on 300. Sorry, handwriting's getting poor. 143 on 300 squared. Alright, so let's work that out. Square root of 2 minus 23 on 25, whoops, squared plus 1/3 plus 143 on 300 squared. And that is 27 on 20. It's a distance, but we haven't got any units, I don't think. Units. So exact, so don't give it as an approximate decimal, although it is an exact decimal. 1.35 would also be an equivalent. 1.35 units would also be a correct answer. So it doesn't have to be a fraction. Doesn't mean you can't use decimals because you have to answer exactly. Just means you can't give rounded decimals. Okay. Okay, so moving on to question 3. 16 marks, so again slightly more than the 15, but it looks like question 4 is going to be the longest question. If we'd done our reading time, we would already be all across that and aware of our timing. Okay, so a school has a class set of 22 laptops kept in a recharging trolley. Provided each laptop is correctly plugged into the trolley after use, its battery recharges. On a particular day, a class of 22 students uses the laptops. All laptop batteries are fully charged at the start of the lesson. Each student uses and returns exactly one laptop. The probability that a student does not correctly plug their laptop into the trolley at the end of the lesson is 10%. The correctness of any students plugging in, that's not a very nice sentence, but yeah, the correctness of any students plugging in is independent of any other student's correctness. Okay, so whether one student plugs their laptop in or not doesn't have an impact on the next student plugging in or not. That's about sort of confirming that you can use a binomial distribution. Determine the probability that at least one of the laptops is not correctly plugged into the trolley at the end of the lesson. Give your answer correct to 4 decimal places. Okay, so I'm going to use a binomial distribution here, so I need to set that up properly before I use it, because there's not a lot of working out to write down when you use your CAS to do them, so you need to make sure that it's clear what you're telling the CAS. Okay, so we want to determine the probability that at least one of the laptops is not correctly plugged in. So not being plugged in correctly is what we're interested in. So I'm going to let X be the number of, in a binomial distribution it's always number of laptops not plugged in correctly. Sometimes you need to be just a bit careful about using negatives and just make sure that you're consistent with how you interpret it throughout the question. And so X is a binomial variable here. There are 22 laptops, so N is 22, and the probability that any one laptop is not correctly plugged in is 10%. Okay, so 0.1. In part A, we want to determine the probability that at least one of the laptops is not correctly plugged in. So we want the probability that X is bigger than or equal to 1. The probability that the number of laptops not plugged in correctly is at least 1. And then we can use our CAS to get that answer correct to 4 decimal places. So menu 55B for binomial CDF. Number of trials is 22, probability of success is 0.1, lower bound is 1, upper bound is 22. So the probability correct to 4 decimal places is 0.9015. Part B, a teacher observes that at least one of the returned laptops is not correctly plugged into the trolley. Given this, there's a conditional probability, find the probability that fewer than 5 laptops are not correctly plugged in. Give your answer correct to 4 decimal places. Okay, so we don't need to redefine our binomial distribution, we've done that in part A. So the definition up here applies until I change it. Okay, so we want the probability that fewer than 5 laptops, so x is less than 5, given that at least one was not plugged in correctly, given that x is bigger than or equal to 1. Okay, conditional probability. The formula for conditional probability is on your formula sheet if you forget it. So it's the intersection of the two things over the second thing. Okay, so that is the probability that x is both less than 5 and x is bigger than or equal to 1 over the probability that x is bigger than or equal to 1. So the denominator we've already worked out. Now the probability of x being both less than 5 and bigger than or equal to 1 is 1 less than or equal to x, which is less than 5. And this is going to be 0.9015 down here. Be careful about the fact that if it's less than 5, when in a discrete distribution like a binomial distribution, that is that x has to be between 1 and 4 inclusive. So just be careful about that when you put it into your calculator. So menu, in fact I can just edit my previous calculation really. Instead of going from 1 to 22, we're just going from 1 to 4 inclusive. So that is 0.8394 over 0.9015. Now I want my final answer to be correct to 4 decimal places, so I don't use rounded answers to work them out. I'm going to use these nice exact numbers in my CAS. There's no reason not to. That number divided by that number, and so correct to 4 decimal places, that is 0.9311. Just to be clear, let me just see what happens if you use the individual answers rounded to 4 decimal places. 0.9311. No, sorry, 0.9015. In this case, it does still round to the same value, but in some situations it might not. So make sure you're working as exactly as you can. And in fact, it's easier to copy and paste your answers down than have to retype in numbers to 4 decimal places. Okay, the time for which a laptop will work without recharging, so the battery life, is normally distributed with a mean of 3 hours and 10 minutes and a standard deviation of 6 minutes. Suppose that the laptops remain out of the charging trolley for 3 hours. For any one laptop, find the probability that it will stop working by the end of these 3 hours. Give your answer correct to 4 decimal places. Okay, so now we've got a normally distributed variable. So we need a new variable and a new distribution. So B is going to be the battery life in hours. No, I'm going to do it in minutes because the standard deviation is in minutes. Okay, B is a normally distributed variable. The mean is 3 hours and 10 minutes. So 3 hours, 3 times 60 is 180 plus 10, so it's 190 minutes for the mean, and a standard deviation of 6 minutes. Now remembering this notation, this is variance here, so you either write 36 or you can just write 6 squared. Okay, find the probability that a laptop will stop working by the end of these 3 hours. Okay, so we want to find the probability that the battery life of a given laptop is less than 3 hours. Okay, or less than or equal to 3 hours. So that will be less than or equal to 180 minutes. So I was just checking whether it should be less than or equal to. Both will give the same answer, but it's important that you accurately interpret the question. So it will stop working by the end of these 3 hours. If it lasts for exactly 3 hours, it's a bit ambiguous. I think either would be accepted here. Okay, so we want our normal probability this time, so menu 552 for normal CDF. Our lower bound is negative infinity, our upper bound is 180, that's the 3 hours. Our mean is 190, and our standard deviation is 6. And so 4 decimal places, 0.0478. It's a 0.0478 chance that a laptop will run out of battery by the end of 3 hours. Okay. A supplier of laptops decides to take a sample of 100 new laptops from a number of different schools. For samples of size 100 from the population of laptops with a mean battery life of 3 hours and 10 minutes and standard deviation of 6 minutes, p hat is the random variable of the distribution of sample proportions of laptops with a battery life of less than 3 hours. Now again, those of you doing methods in 2020, this is not in the study design. Those of you that are, this is such a stupid convoluted thing where look at that very difficult to interpret paragraph of information, really is not complicated at all. This part of the course is so overcomplicated for what you have to do. Okay, so what we want to know here is we've already got our distribution, so samples of size 100, populations of laptops with a mean battery life of 3 hours and 10 minutes. Okay, so we need another variable here. Now I've already used x and b, so I'm going to introduce a new variable, let's say y. Okay, so y is the number of laptops with battery life less than, battery life less than 3 hours. Actually, so to be consistent about that then, let's say less than 3 hours up there. Okay. And so we know that y is a binomial variable. In the sample, we've got a sample of 100 laptops, and the probability that any of them has a battery life of less than 3 hours is what we've worked out up here, 0.0478. Okay. Now, we know that p hat is the proportion of laptops with battery life less than 3 hours in the sample. And so what that means is that p hat is y divided by 100. So if 2 laptops in the sample have a battery life less than 3 hours, the proportion of batteries with a life less than 3 hours is 2 divided by 100. So that means that y is equal to p hat times 100. Okay, so what that means is, essentially we can make it all about y. So if the question is asking us for the probability that p hat is bigger than or equal to 0.06, given that p hat is bigger than or equal to 0.05, that is the same as the probability that x is bigger than or equal to 100 times 0.06, which is 6, given that x is bigger than or equal to 100 times 0.05, which is 5. So it's a conditional probability. So we want the intersection of those two things. So probability that x is both bigger than or equal to 6 and bigger than or equal to 5, which means bigger than or equal to 6, over the second thing, which is probability that x is bigger than or equal to 5. Okay, so menu 55B, it's a binomial CDF. Number of trials is 100. Probability of success, I'm just going to copy this number here. So Control C, because I'm going to need that. Sorry, so menu 55B, let's go back here. So number of trials is 100, probability of success, Control V to paste that number there, working nice and precisely. You know, again, you don't want to use a probability rounded to 4 decimal places to then calculate another probability also rounded to 4 decimal places. You run the risk of compounding that error. So the numerator, the lower bound is 6 and the upper bound is 100. I've got 100 trials. If x has to be bigger than or equal to 6, it can be anywhere from 6 to 100. Okay, so that is the numerator, 0.3443 over probability that x is bigger than 5. I'm just going to edit this from 5 to 100 instead of 6 to 100. So that is 0.5234, and then do that division, that number divided by that number, to 3 decimal places. Now I suspect the answer is asked for 3 decimal places here to avoid the compounded rounding errors, so that if you did use rounded values, it would still round to the same thing. But again, I think there's no excuse for working. It's easier to work exactly with your CAS than not. So 3 decimal places, 0.658. Okay, it's known that when laptops have been used regularly in a school for 6 months, their battery life is still normally distributed, but the mean battery life drops to 3 hours. So remember it was 3 hours and 10 minutes earlier. It's also known that only 12% of such laptops work for more than 3 hours and 10 minutes. Find the standard deviation for the normal distribution that applies to the battery life of the laptops that have been used regularly in the school for 6 months. Okay, so B is still the battery life. So we don't need a new letter. We're not changing that. B is a normally distributed variable, but now the mean is 180 minutes. Not 190 minutes, and we don't know what the standard deviation is, so that's what we want to find. We do know that the probability that the battery life is 12% for more than 3 hours and 10 minutes. Probability that battery life is more than 190 minutes is 12%, so 0.12. We want to use that to find the standard deviation. Your CAS can solve that equation. So we're going to do menu 3.1, and then we want menu 5.5.2, so normal CDF, bigger than 190, so 190 to infinity, oops, not to pi, to infinity. The mean is 180, and the standard deviation we don't know, so I'm just going to call that S. Now my CAS won't like having an unknown in there, but we want to solve that probability. We know that that has to be equal to 0.12. We want to solve that for S, and when you're solving for the standard deviation, you do just need to give it a simple restriction by telling it that the standard deviation has to be bigger than 0. And then you work out, we want the standard deviation correct to 4 decimal places, and so we know that the standard deviation is approximately 8.5107 minutes. Standard deviation has the same units as the variable. Okay, the laptop supplier collects a sample of 100 laptops that have been used for 6 months from a number of different schools and tests their battery life. The laptop supplier wishes to estimate the proportion of such laptops with a battery life of less than 3 hours. Okay, suppose the supplier tests the battery life of the laptops one at a time. Find the probability that the first laptop found to have a battery life of less than 3 hours is the third one. Okay, so these are the laptops that are 6 months old. So the probability that a laptop has a battery life of less than, which was it? Battery life of less than 3 hours, less than 180. Well, 180 was the mean, and so that's 0.5. I mean, you can confirm that with a normal CDF, but, you know, less than or equal to 180 when the mean is 180. It doesn't even matter what the standard deviation is. It was 8.5-ish or something. It's going to be 0.5. That's just a rounding issue with your CAS. Okay, so we don't need that at all. Less than the mean. So, you know, being clear about the fact that this is probability that B is less than the mean, and so therefore it is 0.5 or 1/2. Find the probability that the first laptop found to have a battery life of less than 3 hours is the third one. So they're chosen one at a time. Okay, so that means we're going to need to find, it'll be the probability that the battery life is more than 3 hours for the first one, and the battery life has to be more than 3 hours for the next one, and the battery life has to be less than 3 hours for the third one. Okay. After that, it doesn't matter, so all these probabilities would just be 1, so that's irrelevant. So probability the battery life is more than 3 hours is 0.5, probability it's more than 3 hours is 0.5, and less than 3 hours is also 0.5, so it's 0.5 cubed or 1/2 cubed, so it's going to be 1/8, or what's that, 0.125. The laptop supplier finds that in a particular sample of 100 laptops, 6 of them have a battery life of less than 3 hours. Determine the 95% confidence interval for the supplier's estimate of the proportion of interest. Okay, so what we need for our confidence interval is our n value and our p-hat value, which is going to be 6 out of 100. Okay, so we know here our n value, our sample size is 100, and the proportion of laptops that live less than 3 hours in this sample is 6%. Okay, 95% confidence interval we can do using our CAS. So it is menu 5, no, sorry, it's not 5. Sorry, it's menu 6 for statistics. Sorry, it's in 2020, I haven't taught this year. And 6 for confidence intervals. We want, which one do we want again? I think it's 1 prop Z interval. Let me just check. Yes, so 1 prop Z interval, so 5. We want the number of successes we had in the sample of 100, so that's actually 6. So 6 is the number we're going to put in, not 0.06. N is 100, and we want a 95% confidence interval. And when we do that, why did nothing happen there? Let me do that again. Menu 665, successes is 6, n is 100, confidence interval, I think I might have gone to cancel, not okay. Okay, and so our lower value of our confidence interval is 0.0135. What do we want? 2 decimal places, so 0.013 and 0.11. So the 95% confidence interval is always given as an inclusive interval from 2 decimal places, so just 0.01 to 0.11 to 2 decimal places. Sorry, it should be a non-included interval. Okay, so there's our 95% confidence interval. Okay, part H, so again 2020, so the confidence intervals wasn't for those of you in 2020. Part F you should have been able to do in 2020, so it's just parts D you should have skipped in 2020 and part G skip in 2020. And then part H here is a continuous random variable, so you can also skip this. The supplier also provides laptops to businesses. The probability density function for battery life, X in minutes, of a laptop after 6 months of use in a business is given by this. Find the mean battery life in minutes of a laptop with 6 months of business use. Okay, so we know that the expected value of X is going to be the integral over the domain, which is from 0 to 210, of X times the function. So 210 minus X, and we'll write that over 400. 210 minus X on 400 times e to the X minus 210 on 20. I'm just going to define that function because we'll probably need it. So I'm going to define f of X as being equal to 210 minus X over 400 multiplied by e, make sure you use the proper e, it's X minus 210 over 20. Okay, so I want to do shift plus, so an integral from 0 to 210, 210, of X times f of X. So you can just write f of X in your working here. In fact, that's probably what I would have done. I know it's a piecewise function, but given that you're integrating from 0 to 210, it's implicit that that is the part of f of X that you're interested in. Even if you do integrate 0, you still don't get anything, so it's fine to just write f of X. And we want to differentiate that with respect to X in the CAS, X. And we get, group 2 decimal places, so control enter. So a mean value of 170.01 minutes. Okay, so that's the mean battery life, so a bit less than 3 hours. Find the median battery life in minutes of a laptop with 6 months of business use. So that just means that we're using this function, correct to 2 decimal places. Okay, so if we let m equal the median, then the integral from 0 up to the median of f of X has to be 0.5. So we're going to solve. Now if I wanted an exact answer, I would make it equal to 1/2 rather than 0.5, but I want an answer to 2 decimal places anyway, so I'm going to type in the 0.5 to help force that. And that's because my calculation mode is set to auto, so if I get an exact value and I want a rounded value, I just press Control Enter. Sorry, we're solving this for m. Now obviously we know that m has to be between 0 and 210, and so therefore it has to be 176 2 decimal places, 0.45. M is 176.45, and that is since we know that m has to be somewhere between 0 and 210. Okay, and then on to the final question of the paper, question 4. This is a 21 mark question, so this is a quarter of the paper here on its own, question 4. Okay, express 2x plus 1 over x plus 2 in the form a plus b on x plus 2. Lots of ways you can do this. I tend to do this by hand by doing what I call forcing the numerator into the denominator. So 2x plus 1 over x plus 2, sorry, x plus 2. So the only way you're going to be able to cancel the x's out of the numerator, which is what you want here, is if there is x plus 2 in the numerator. So I always start by writing x plus 2 in the numerator, and then I work out what has to go around that to make sure that these are still actually equal. So there's going to have to be a 2 out the front here to get the 2x. That will give me 2x plus 4, but I only want plus 1, and so there will need to be a minus 3 here. Okay, and so that means that you've got 2 times x plus 2 over x plus 2, take away 3 over x plus 2. The x plus 2's cancel out there, and so we get 2 minus 3 over x plus 2. And so therefore a is 2 and b is negative 3. You can get your CAS to do that, because you can get your CAS if you do, what am I trying to do here? Menu 3 for algebra, or you can use the number menu as well. Fraction tools, number 9. If you want a proper fraction, if you give it an algebraic fraction, it'll make sure that the polynomial degree on the numerator is less than the one on the denominator. So if you type in your fraction here, 2x plus 1, oops, 2x plus 1 over x plus 2, it will give it to you in the form that you want. So a is 2 and b is negative 3. Find the rule and domain of the inverse of f, of f to the negative 1, the inverse of f. Okay, so we want to let f of y equal x, and we're going to solve that for y. Now I'm going to define a function here, menu 1, 1. I'm going to define f of x as being equal to 2x plus 1 over x plus 2. And I'm going to get my CAS to help me here possibly, see what it gives me. Sometimes it's a bit ugly. If I solve f of y equals x for y, it's not too bad. That means we get 2y plus 1 over y plus 2 equals x, and it gives you y equals, now I'm going to expand that out, I hate the way it factors out negatives, so that is 1 minus 2x over, x minus 2. Okay, so therefore the inverse function is 1 minus 2x over x minus 2, and the domain, so reading your question, so that going back once you're getting to the end, go back to read it, find the rule and domain of the inverse. So the domain of the inverse is equal to the range of the original. Okay, so thinking about your original function, so your original function is equal to 2 minus 3 on x plus 2. So that's negative 3 on x plus 2 plus 2. So it is a reflected hyperbola that's gone to the left by 2 and up by 2. So you've got an asymptote at x equals negative 2 and at y equals 2, and it's reflected, so it's in these quadrants. Okay, so the range is going to be all real numbers except for positive 2, and so therefore that becomes the domain of f, real numbers except for 2. That also makes sense because if x were to equal 2, the denominator of your inverse function would be 0, and that's why 2 is not in the domain. Also worth noting, it might be worth just getting your CAS to do the proper fraction again, so menu 3, 9 for fraction tools, 1 for proper fraction. See if it will be okay with the y in the way there. Yeah, so if you rewrite this, this is the same as negative 3 on x minus 2 minus 2. So that might be an easier way to think about it when you want to think about the sort of graphs in the next parts that I can see are coming. So they're both hyperbolas. Okay, part of the graphs of f and y equals x are shown in the diagram below. Okay, so here is part of f, so there's another part up here, but we've got part of f down here and y equals x in the diagram below. Find the area of the shaded region. Okay, so first of all I need to find those points of intersection. So we want to make f of x equal to x. So let's solve that. Solving f of x equal to x for x. And so we get x equals plus or minus 1. and so therefore the area is going to be equal to the integral from -1 to +1. It's an area between two curves, so it's the top function, which is f of x, minus the bottom function, which is x. You don't need to rewrite out f of x. It's clearly defined throughout this whole question. You can just refer to f of x. So use of function notation makes things really efficient here. So shift plus, integrating from -1 to 1, f of x, f of x minus x with respect to x. Okay, so that is 4 minus 3 times log e of 3, and it's an area, so square units. That's a 1 mark question, so it's really just for the answer. It probably could have been worth 2 marks to find your x values, although you could probably read them off the graph, but I'd be very cautious about reading numbers off a graph. But it certainly does confirm that it's definitely, you could see here it was definitely somewhere like -1 to 1, and yes, indeed it is. Okay, part 2, part of the graphs of f and the inverse of f are shown in the diagram below. Find the area of the shaded region. Okay, so we can do exactly the same thing. We can find when f of x equals the inverse of f. We still need to do this, so menu 3.1. Solve f of x equal to, now I haven't got the inverse defined, but it was this function up here. Just need to get rid of that extra little y equals that's in there. So that was my inverse function. I'm going to make them equal. Now actually, if I'd thought a little bit about this, I didn't actually need to do that, because we know that when an inverse and its original function intersect, that is because they intersect on the line y equals x. So we know that it's the same points we found in the previous question. The other thing we know is that these areas are going to be symmetric about the line y equals x, because it's a reflection in y equals x. So that blue area there, which we found in the previous part, is going to be the same as that pink area there. Okay, and so the area is going to be technically the integral from -1 to 1 of f of x minus the inverse of f. And look, when you've got your CAS, it's just as easy to work that out. But actually, if you recognise the symmetry you've got here, it's actually just 2 times the area that you found in the previous part. So it's just 2 times, what was our answer up here? 4 minus 3 log e of 3. And so it is going to be 8 minus 6 log e of 3 square units. So it's really just 1 mark, because you're really just meant to recognise, oh, all I need to do here is double my answer from the previous question. Okay, part C. Part of the graph of f is shown in the diagram below. The point P, which has coordinates of CD, is on the graph of f. Find the exact values of C and D such that the distance of this point to the origin is a minimum. Find this minimum distance. Okay, so we want to minimise the distance from P to O. So we need to come up with an expression for the distance from P to O, which means we need to think about the the coordinates of point P. So given that we know the equation, we know what y equals f of x is, that means that the coordinates of point P, so the y coordinate is actually just f of c. Okay, so the point P has coordinates of c, f of c. That's not going to be a very nice expression, so I'm just going to refer to it as f of c. And so that means that the distance from P to O, I'm going to call it capital D, is going to be the square root of, now it is going to be c minus 0 squared plus f of c minus 0 squared. Okay, so we can get an expression for that, and then we can work out the derivative of that. So let's just do that. Square root of c minus 0, don't know why I've got square brackets, let's go again. C minus 0 squared plus f of c minus 0 squared. Obviously I don't really need to write in the minus zeros. So that's pretty horrible. So I'm actually not going to bother writing that out. I'm just going to leave it written like this. Okay. And so then the derivative of the distance with respect to c, I want to make that equal to 0. So I might define this as being d of c, the distance in terms of c. It's going to be that. So I then want to solve the derivative of that, shift minus. Sorry, I don't like using d because of the dd's. Sorry, it's the derivative with respect to c of d of c. We want that to be equal to 0. We want to solve for c. Okay, and we find that c is equal to, again, expanding that negative out the side of the bracket, you get negative root 3 minus 2. So it's actually minus 2 plus or minus root 3. Okay, but what do we know about c? It certainly looks like it is negative, but that's just the diagram. It's clear from the diagram that it's not going to be over here where you've got the shortest distance. But equally, we want to think about which values of c give minimum distance. So I'm just going to get those as decimals. So it's about negative 3.7. Okay, so I'm going to do a Sine diagram here to show which of those gives a minimum distance. So we're going to have c, we're going to have dc, and we're going to have the shape. And we're going to have to think about a number of places. Okay, so we don't need these bits out here, but that's okay. Alright, so we're going to look at negative 2 minus root 3 and negative 2 plus root 3. So we know the derivative at these 2 points is 0, and therefore the graph is flat there. I've got those decimal approximations, so this one is about negative 3.7. Sorry, negative 3.7. And this one's about negative 0.26. So in fact, they're both negative, but we can see that, well, in fact, actually, sorry, we can ignore this straight away because negative 3 is out of the domain of what we're looking at. So it'd have to jump over the asymptote, therefore you'd be going to somewhere actually up here on this branch up here. So it's definitely got to be all about this one, but we want to make sure that we're actually getting a minimum distance rather than a maximum distance. So I'm just going to sub in some points to the left of that, somewhere between negative 3.7 and negative 0.26. I might do negative 1, and then we might just do 0 here. So I'm going to work out the derivative at each of those points. So shift minus the derivative with respect to c of d of c, given that, and once I get on a roll here this will be quick, given that c equals negative 4. Okay, so that's about negative 0.26, so it's a negative gradient. When c is negative 1, control enter, that's also a negative gradient. Okay, and when c is 0, that's a positive gradient. Okay, so what we have here is negative gradient, 0 gradient, negative gradient, so that's a stationary point of inflection, 0 gradient, and then positive gradient. And so therefore, when c equals negative 2 plus root 3, distance is minimized. We can also be clear from having thought about both stationary points, there's only 2, and the graph obviously goes up from here and here, so this has to be the lowest point of the graph. Okay, it's an absolute minimum as well. When c is negative 2 plus root 3, distance is minimized. Right, let's work out what the question asked us for. Find the exact values of c and d such that the distance of this point to the origin is a minimum, and find this minimum distance. So we've got 3 things to find here and 3 marks, so that's all we're going to need to do. Exact values of c and d. Now it doesn't even need to say exact values, that's implied, we know that from the standard instruction. And we want to find the minimum distance. Okay, c equals that. This means that d is f at negative 2 plus root 3. And so that is f at negative 2 plus the square root of 3. That is 2 minus root 3. And so that's the value of d, and then the minimum distance. So I'm going to sub that into my distance equation. So d of c, which is negative 2 plus root 3. The minimum distance is 2 root 2 minus root 6. Okay, so there's my three answers, my value of c, my value of d, and my minimum distance, all given exactly. Okay, let G be another hyperbola of a similar kind of format. So we've just done this specific example where we were looking at 2x plus 1 over x plus 2. And so now we're thinking about, and we looked at that with a domain from negative 2 to infinity, and we looked at this here. Okay, we just looked at that bit of it. And so we are now looking at a general version of what we've just seen above. Show that x1 less than x2 implies that g of x1 is less than g of x2, where x1 is an element of negative k to infinity and x2 is an element of negative k to infinity. Okay, so let's have a think about what's happening here. Let's have a look at g of x. We want to show that, so we want to be a bit explicit, but we certainly sort of have a sense of what this looks like. K has to be a number bigger than 1. So let's just define this function in case that's useful to us. So define g of x equal to, make sure you put the multiplications in, so it's k times x plus 1 over x plus k. Okay, I am just going to do the proper fraction here to have a look at what it looks like as a hyperbola. So menu 3, 9 for fraction tools, 1 for proper fraction. I'm going to turn g of x. Okay, so we know that it is kx plus 1 over x plus k, but we know that that's the same as negative k squared minus 1 over x plus k. Plus k. So it's a hyperbola with a translation to the left by k and a translation up by k, and it's the negative at the front here suggests that it's reflected, and it certainly is reflected because k squared minus 1 is going to be a positive number because k has to be bigger than 1, k squared therefore is bigger than 1, k squared minus 1 therefore is bigger than 0. Okay, and so we know that since k squared minus 1 is bigger than 0, this means that we have a reflected, well actually maybe it's easier to write this as, let's do it this way, 1 minus k squared. So since we know that 1 minus k squared is less than 0, that means that we have a reflected hyperbola. So the graph shape is going to go this way. And we know that it is also translated left by k because k has to be bigger than 1. So if you're adding on k, it must be going left because k is a positive number. Left by k and up by k. Okay, so that means that we're going to have a hyperbola left by k and up by k. X equals negative k, y equals k, and because we only want to draw it over the domain where x is bigger than negative k, we're actually only interested in this part of it. Now obviously depending on what k is, it's going to be more extreme than that, it's going to be closer to them, or it might be further away from the asymptotes than that, but the graph is going to be essentially following this shape, and those asymptotes aren't going to move anywhere. Okay, so this is bringing to mind for me. This is talking about the function being strictly increasing. So I'm basically trying to show here that this function is strictly increasing over that domain. So we can see that over the domain where x is an element of negative k to infinity, g, sorry, it's not called f, g is a strictly increasing function, which means that if x1, x2 are both elements of that same domain, then if x1, which way did they write it up here? If x1 is less than x2, that means that g of x1, so the y value at x1 has to be lower down than the y value at x2, and that's the definition of a strictly increasing function. Okay, so if you've got, x1, that would be g of x1, and then if you have x2, that y value would be g of x2. And that would be true no matter where you picked those two values. The y value at the bigger x value will always be bigger because it is a strictly increasing function. So the key idea is that you want to show that it is strictly increasing. The solution in the examiner's report does quite a lot of algebra to show this, but I think we've clearly given a graph. We've justified that as long as, because k has to be bigger than 1, that means that has to be less than 0, so you've got a reflected hyperbola with its asymptotes at x equals negative k and x equals k, so it's going to look like this all the time. It's strictly increasing, and so therefore that means that this property is true. Okay, so obviously drawing the graph is part of that. That's part of the illustration of showing that it's a strictly increasing function. Okay, E. Let x be the point of intersection of the graphs of y equals g of x and y equals negative x. Find the coordinates of x in terms of k. Okay, so we simply want to solve g of x equal to negative x, so let's do that on our CAS. Let's solve g of x, g of x equal to negative x for x. Okay, and we get that x equals, now again, your CAS does horrible things with negatives. If you expand out that negative there, you've got the negative square root minus k. So in both cases, it's negative k plus or minus the square root of, sorry, that's a bit bigger, square root of k squared minus 1. So they are the x coordinates. Now it asks us for the coordinates, so we're going to need to work out, oh, actually no we don't, because we know that it intersects with y equals negative x, so the y coordinate will be the negative of the x coordinate. Now also though we've got a domain restriction, sorry, so we're not interested in both of those, so g of x is only from negative k to infinity, okay, and so therefore, but we know that x has to be bigger than negative k, and so it can't be the negative k minus something, because that would be smaller than negative k. So x must be negative k plus the square root of k squared minus 1. Now we want the coordinates, but as I said, the y coordinate, y is equal to negative x, so the y coordinate will just be the negative of that. And so therefore the coordinates of x are, the x coordinate is negative k plus the square root of k squared minus 1, and the y coordinate will be positive k minus the square root of k squared minus 1. So just the negative of that. Find the value of k for which the coordinates of x are negative a half, a half. Okay, so you could solve two different things here. That thing equals negative a half, or that thing equals a half. It's the same thing either way. Okay, so k minus the square root of k squared minus 1 equals positive half, or negative k plus the square root equals negative a half. It's the same information. Okay, so let's solve that. I'm just going to type that in. Solve k minus the square root of k squared minus 1, and that has to be equal to a half, solving for k. And so we find that k is equal to 5 on 4. So 2 marks, 1 for an equation, 1 for an answer. The previous question, 2 marks, I think would just be for the coordinates, the x-coordinate and the y-coordinate. Okay. Alright, let z be negative 1, 1, y be 1, 1, and x be the vertices of the triangle, and x be the vertices of the triangle x, y, z. Let S of k be the square of the area of the triangle x, y, z. Find the values of k such that S of k is bigger than or equal to 1. Okay, so we want to think about S of k is the square of the area of the triangle. So we have to come up with a way of describing the area of the triangle. Okay, so let's be clear about what we know here. So this point z is negative 1, 1. This point y is 1, 1. To find the area of the triangle, we're going to need the base length, which I'm going to do as that length there, which should be easy enough. We've got those 2 points, but we're also going to need the height, which will be that. Now we're going to need to show, though, that for it to be the height, it has to be perpendicular to that line there. So we're going to need to think a little bit about that. Okay, that's the origin at least. Oh, actually we know here that the gradient of this line is, so that's 2 and 2, so it's 2 over 2, so gradient is 1. And so therefore that means that if they're going to be at right angles, the gradient of that line has to be negative 1. So what we want to do is then we know the equation of that line. So this, let me draw them as 2 separate colours so it can be clear what I'm talking about. So this line is perpendicular to that one, so we know it has a gradient of negative 1. Now actually we know they both go through the origin, so the equation of the pink line is y equals mx plus c, 1 times x plus 0, so it's just y equals x, and the equation of this line is y equals y equals negative 1, so mx plus c, so negative x plus c, so, and again c is 0. So we've got the equations of those 2 lines. So we actually just want to know, so the coordinates of this point x are where the line y equals negative x intersects with g of x, and that's what we've just done up here. So that's this point x here. We've got the coordinates of x. Sorry, yeah, we've already thought that through. So we know those already. So the coordinates of that point, what was it again? Negative k plus the square root of k squared minus 1, and k minus the square root of k squared minus 1. Okay, so we want to find the area of that pink triangle. So we want to find the distance from z to y, which, as I said, if we just think about the triangle there, that's 2 and that's 2. Sorry, just trying to make my 2's not look like z's. So yz squared is 2 squared plus 2 squared. So it's 4 plus 4, which is 8. And so yz is the square root of 8, which is 2 root 2. Okay, and then we can work out an expression for that perpendicular distance. So from the origin to this particular point here is obviously going to be, let's think about that. It's going to be a bit ugly, but that's okay. We could probably just do it as a Pythagoras, but I think I'll just do it as a distance between 2 points. So I know that xo is going to be the square root of negative k plus the square root of k squared minus 1, take away 0, all squared, plus positive k minus the square root of k squared minus 1, take away 0, all squared. Alright, so let's maybe just see if we can get a slightly neater expression for that. I don't think it's going to be nice. Oh, sorry. Negative, brackets, sorry. Negative k plus the square root of k squared minus 1, and we want all that to be squared, plus positive k minus the square root of k minus 1, k squared minus 1, and we want that squared. Okay, so this is square root of 2 lots of square root of k squared minus 1, take away k, all squared. Okay, and so therefore S of k is the area of the triangle. So the area of triangle, what is it, XYZ, is going to be half times the base, which is 2 root 2, times the height, which is this expression here, square root of 2 square root of k squared minus 1, take away k, all squared. Okay, so we're going to have half times 2 root 2, which is just going to be root 2, obviously. Sorry, 2 root 2, and then times that. Okay, so we actually get 2 times the square root of k minus square root of k squared minus 1, all squared. And so then S of k is the square of the area. So S of k is that squared, which means it's going to be 4 times k minus the square root of k squared minus 1 squared. Now actually, if we think about it, this expression here, I don't know why the CAS didn't simplify it. If we've got the square root of that squared, that is just 2 times k minus the square root of k squared minus 1. And so when we square that, we're just going to get 4 times k minus the square root of k squared minus 1, all squared. Okay, so we now have S of k, and we know that S of k, in this question, we want S of k to be bigger than or equal to 1. So that is 4 times k minus the square root of k squared minus 1, all squared, has to be bigger than or equal to 1. So we want to solve 4 times k minus the square root of k squared minus 1, that squared has to be bigger than or equal to 1. We want to solve that for k. Okay, so when we solve that with our CAS, I'm going to write that down, but we just need to think. So we get k can be between 1 and 5 on 4 inclusive, or k can be less than or equal to negative 1. But we know from the original definition of g that k has to be bigger than 1. And so that has implications for, obviously ignoring that, but also has implications for that, okay? In that k actually can't equal 1. And so therefore 1 is less than k, which is less than or equal to 5 on 4, is our final answer there. Okay, so the graph of g and the line y equals x enclose a region of the plane. The region is shown in the diagram below. Let a of k be the rule of the function a that gives the area of this enclosed region. The domain of a is 1 to infinity. Okay, so that is that k has to be, it's still saying that k has to be bigger than 1. Okay, so yeah, this sentence here is essentially still telling you k is bigger than 1. Okay, so now remembering that g of x is, it's got asymptotes when x equals negative k and when y equals k. So if we change k there's going to be some, but those asymptotes don't move at all. But changing k, there could be, dilation. So the value of, sorry, I'm just going to be clear. Yeah, so the value of k could change, but we also know that it'll always go through the points 1, 1 and negative 1, 1, because we know that when we solved g of x equal to x, actually let me just check that. If I solve g of x equals x, to find where it's going to cross, we're going to solve for x. It's always x equals plus minus 1. So the graph could be dilated, more or less. So that area will change, but it's still going to go through those same 2 points, and it's still going to be bounded by the asymptotes. Although actually the asymptotes are less relevant because of these points. So give the rule for a of k. Okay, so let's just get a rule. So we know that the area in terms of k is going to be the integral from negative 1 to 1 of g of x minus x. So let's get Kaz to do that for us. From negative 1 to 1 of g of x with respect to x. And that's pretty horrible. Let's think about how we can do that more efficiently than that. Okay. Well, actually, it's not that horrible because it looks horrible because of those modulus or absolute value signs. But remember, we know that k has to be bigger than 1, which means that k minus 1 will always be a positive number and k plus 1 will always be a positive number. So we can ignore those absolute value signs, and we can just write this area as being k squared minus 1 times log e of k minus 1 over k plus 1 plus 2k. Okay, so we want to show that a of k has to be between 0 and 2 for all k bigger than 1. So that area is always going to be between 0 and 2. Okay, so there's a couple of ways we could do this. One is sort of, I guess, a kind of brute force method, which is to actually think about what the function, what the graph of a of k were to look like. So if we were to, let me define a function. When you, sorry, what am I doing? 1, 1. If I define a of k as being equal to this thing, I'm just going to get rid of those modulus signs just so that that's not too bad. So it's going to be k minus 1. Actually, no, I might leave them there just for the definition. Sorry, NU11, I'll just see what happens. A of k equals that. Okay, then if we pop over here to the graph, and let's have a look at, now my graph won't be able to sketch a of k, but I'll just type a of x in here. Sorry, a of x. And we only want, we know that that is where x has to be bigger than 1, because k has to be bigger than 1. Okay, so we know that x is bigger than 1. Alright, so if we have a look at that graph, so let's just do some editing here so we can sort of see what's happening a bit more clearly. Too high. Okay, so that's essentially the graph there. So if we have a look at what does a of 1 actually equal, so let's go back over here. A of 1, oh, is undefined, sorry, because that's not included. That's a good point. So let's go back to here. We really need a limit, which I don't really want to get into here. So let's see if we can graph trace 1 graph trace. So let's have a look what happens. As we get closer and closer to x equals 1, I suspect it's getting closer and closer to 2. Well, why don't we have a look at drawing in the line y equals 2. Oh, sorry, not y equals 2. Okay, so that certainly seems that that is where it is approaching, or it's certainly clear anyway that a of x is less than 2 all the time, looking at those graphs. Okay, we could check that, oh sorry, we could check that over here. We could, oh sorry, we could solve a of x less than 2 for x, or a of k, sorry I should have done. Thought it would tell us that was true. Anyway, so, my apologies. So a of 1 doesn't exist, but if we have a look at that graph, what we're actually seeing here is that this is, well actually if we draw it without the restriction, that's going to be the better way I think perhaps. So if I, if I try and draw it, if I just draw a of x, there we go. Now we should be able to find where they intersect. F1 of x equals F2 of x, or when a of x equals 2. Let's go back over here now and see if it will solve this. Sorry, that's not what I meant. Let's solve that equal to 2. It's not technically defined at that point, that's the problem. Okay. If I were to solve, let me see what happens if I solve f1 of x equal to f2 of x here. If I solve f1 of x equals f2 of x for x, yeah, we get those same solutions, and they're really not helpful because we've got that scientific notation. And again, it's because actually this function isn't defined when x equals 1, because it would give you log of 0, which isn't defined. That's the problem. And that's why k has to be bigger than 1. Sorry, and I have realised I haven't actually copied that out correctly, have I? Those should be k's. We haven't actually answered that question right. Okay, if you were to sketch a of k though, what it does look like, if there was a way for us to do it, we can certainly see that it's all less than 2, and so we can definitely see that if we sketch a versus k, we had the point 1, 1, 2, and asymptotic behaviour happening like that. And so we could say that it can be seen from the graph of a versus k that a of k is less than 2 for all k bigger than 1. Okay. That's probably, it's not really the intent of the question. What they actually want you to do is think about what you've done here with the triangle. Okay, so what you want to think about with the similar idea with the triangle, but a slightly different triangle. So what we want to think about actually is that we know that no matter how we change k, it's still going to go through these 2 points. Those 2 points are fixed, and so it will dilate and change shape as a changes, but it's always going to be limited by, it's never going to go past this triangle, so it's going to get more and more extreme, but it's never actually going to get bigger than that, because if it did, you would have to, the minute the gradient of this graph becomes, we know that it's a strictly increasing function, we've already showed that, so the gradient will always be positive, and so therefore even if it's very, very small positive, it's still going to fit within this triangle here. Okay, so the point is that we've sort of got this boundary, so we kind of want to be able to sort of show that. Oh, sorry. Let me make this explanation a bit smaller so I've got a bit more space. Okay, so we want to be able to think about the fact that we know that, let's just draw this graph down here so we can see it. Sorry. So we know we've got our asymptotes at y equals k and x equals negative k. We've got the line y equals x. Okay. And then we've got g of x. And we know that g of x and y equals x, no matter what the value of k is, they always intersect at these 2 points. Okay? So, therefore, because g of x is a strictly increasing function, so it always has to have positive gradient, it means the curve can't come around under here, so it's always going to sit above y equals x, between -1 and x equals -1 and x equals +1, and it is never going to have an area that is bigger than this pink triangle here. Okay, and that pink triangle, that distance there is 2, and that distance there is 2. Okay, so perhaps since g of x is a strictly increasing function, and g of x and y equals g of x and y equals x intersect at x equals ±1 for all k bigger than 1. So whenever k is bigger than 1, and for all x bigger than -k. So that is x bigger than -1. This means that g of x is bigger than x for x between -1 and 1. So that means the hyperbola will always sit above the line y equals x, and so that means that a of k always has to be positive, always going to get a positive area. Okay, so we definitely know that. And we also know that because the gradient is always positive between -1 and 1, so this means since the derivative of g is bigger than 0 for x between -1 and 1, the area is bounded, the area a of k is bounded by the pink triangle. Shown. So this means that a of k has to be less than half times 2 times 2. So that means a of k has to be less than 2. And so therefore a of k has to be somewhere between 0 and 2. So it's really about it being strictly increasing, and so as I said, it can get steeper and steeper, so more steep here at -1 and less steep here at +1, but it's never actually going to get, because you can't have a negative gradient, it can't slope back this way outside of that triangle, and it can't slope down this way from outside of that triangle. So it's always going to be bounded by that pink right-angled triangle, which, just using the coordinates of -1, 1 and 1, 1, has an area of 2, and so therefore the area of k, it'll always be above y equals x, so it'll always be positive, but it has to be less than 2. And so that is the end of the 2016 exam.